Alright, once again, I'm your teacher, Mr. Hyper, and our today's lesson is covering Senior 5 and Senior 6, and we are basically looking at physical chemistry, the part of ionic equilibria having a subsection of buffer solutions. Before we start our lesson, I would request that we subscribe to this channel, Hyper and Chauffeur Academic channel. You can like and share the link to the rest of the people so that the link is spread all over for the best lessons of ours. We are going to look at buffer solutions, and buffer solution, to bring it to a real perspective, it is that solution that resists changes in pH when a small amount of a base or an acid is added to them. So it's like when one is fighting you, all right, and maybe you are also energetic. So that kind of resistance that you put in order not that person to defeat you, I will not say that you are a buffer, but you're also putting that resistance, all right? So those solutions that resist pH changes, because ionic equilibria, in most of the cases, we normally entirely deal with the pHs, but there comes an extent whereby the pH changes are resisted. So the solutions that resist pH changes, that resist increase or decrease in pH when an acid or an alkali or a base is added to them, are called buffer solutions. So I will first note for you and say that a buffer solution, we say that a buffer solution is a solution that resists pH changes when a small quantity, of a base or of an acid, or a base is added to it. So that is what we call a buffer solution. Now, buffer solutions can be categorized into two. We've got an acidic buffer. We've gotten an acidic buffer. Let me say types of buffer solutions. And we've gotten what you call acidic buffer and alkaline, or what you can call basic buffer. Now we are going to look at the details of each of these, because these ones are the main points that we need to understand before we start looking at the calculations. So when I say acidic buffer, this is a buffer made by mixing a weak acid, and its salt of a strong base. Now, allow me first to remove this so that I first talk about this one in detail. We've said that acidic buffer is that buffer made by mixing a weak acid and its salt of a strong base. So here you have to think of weak acids and then strong bases. For example, if you think of weak acids, I'm giving examples of acidic buffers. We have a weak acid like methanoic acid. Methanoic acid. Methanoic acid is HCOOH. And that is a weak acid. But we've said that we are mixing a weak acid and its salt of a strong base, meaning that we have the salt of methanoic acid. So the salt of methanoic acid will be derived by having HCOO. It would be ions, but there must be a salt of a strong base. Examples of stronger bases, we normally have sodium hydroxide. So by putting Na here, this one becomes a salt of a weak acid. And that is what we are meaning. Salt of a strong base, sorry. Now, but it is mixed, it is within the weak acid. So therefore, an example can be methanoic acid and sodium methanoate. This is called sodium methanoate. Sodium methanoate. So this is one of the examples of acidic buffer. Example 2, you can have ethanoic acid. Of course, this one is HCOONA. Then another example, we have ethanoic acid. We shall have ethanoic acid. And ethanoic acid is CH3 COOH, and its salt, the salt we derive from ethanoic acid, will be sodium ethanoate. So we shall have sodium ethanoate, and sodium ethanoate has gotten a formula whereby you just replace H, the acidic content, or the proton. We replace it with a metal of a strong base. And therefore, we are going to have it as CH3 COONA. That is sodium ethanoate. You can also have a weak acid like propanoic acid. You can have propanoic acid. Propanoic acid is written as CH3 CH2 COOH, and its salt will be sodium propanoate. It will be sodium propanoate, and this is going to be, we shall just replace the proton with sodium. So sodium propanoate is CH3 CH2 COONA. That is our sodium propanoate. So all these ones that I've written here are examples of acidic buffers. Also, we can have hydrocyanic acid. We can have another example as hydrocyanic acid. And that hydrocyanic acid, this is hydrocyanic acid. Hydrocyanic acid is HCN. Don't read it as hydrogen cyanide. This is hydrocyanic acid, HCN, and its salt will be sodium cyanide.
we replace the hydrogen or the proton with the sodium. So we shall have sodium cyanide. So there are very many examples of buffer solutions that you can derive. You can also have carbonic acid, all right? You can also have carbonic acid and sodium hydrogen carbonate. That one will also make a buffer. We can have carbonic acid. Carbonic acid is H2CO3 and sodium hydrogen carbonate. Sodium hydrogen carbonate is NaHCO3. Now, all these mixtures I've written here, the mixture of methanoic acid and sodium methanoate forms an acidic buffer. The mixture of ethanoic acid and sodium ethanoate forms an acidic buffer, and all these others. So, I see Benson smiling. It means he has already understood it, and he's smiling too much that the thing is very clear. Thank you for understanding, Ben. Now, we are going to continue. These ones were among the examples of acidic buffers, but you can suggest as many as possible. So allow me put ETC. After having understood what an acidic buffer is, we need to also understand what an alkaline or what a basic buffer is. So allow me remove this and I put examples of alkaline or basic buffers. All right. So when we say alkaline buffers or when we say basic buffers, basic or alkaline buffer. An alkaline buffer, now on the other hand, this is a buffer or solution, is a solution made by mixing a weak base, by mixing a weak base. We mix a weak base and sort of a strong acid, and it's sort of a strong acid. So in this particular case, you need to be knowing, for example, the most live example that I will give you, I can give you a weak base, that is ammonia solution, e.g. ammonia solution, or one can call it this ammonia solution, or one can write it as ammonium hydroxide. So when you find ammonium hydroxide somewhere, don't be very much worried. Ammonia solution is the solution of ammonium hydroxide. So we have ammonium hydroxide, and because we all know that ammonium hydroxide is a weak base. So if ammonium hydroxide is a weak base, now what about its sort of a strong acid? We've seen strong acids like sulfuric acid, hydrochloric acid. So if I need the sort of that strong, if I need the salt of ammonium hydroxide but from a strong acid, I can use ammonium chloride. Ammonium chloride. Why am I using ammonium chloride? Because the chloride ions are from hydrochloric acid, which is a strong base. So this mixture here, a mixture of ammonium chloride and ammonium hydroxide, is what we call a basic or alkaline buffer. Margaret, have you understood it? Interesting. So basically, this is all about buffer solutions, but we need to go ahead and look at how do they function. We need to go ahead and look at how do they function.